Okay, good morning, everybody. Welcome to WA1 Physics classroom. Today, the video will be particularly targeted at the debrief for my WA1 test for my student. The topic for this test is actually on light. Okay, everything about light, ranging from reflection, refraction, to all the way to lenses. Okay, so let's look at the paper. Need the paper, or it will be in the sharing drive in my description bar below. Okay, you can take a look at the paper in the sharing drive. Okay, if you have your paper, okay, and it's good that you can take out paper and go through your workings and corrections, check out what are the mistakes they make actually along the way. Okay, so let's look at this particular paper. Now, the first two questions, I will not go through much. The first two questions is a typical, I would say it's quite easy questions. It's basically what we look at is the property of reflection. Okay. Question 3 is you will need some, fundamentally it tests the concept of reflection. What we're looking at is angle I equal to angle R. Okay, but what we add on here was the basic of geometry. So the students will need to do some geometry calculations. So for example, right, if I were to use the law of reflection, so incident angle is 30. So this will be angle 30. Okay, so automatically, which means that this angle here, which is your angle R, it will be 30 degree. Okay, angle I equal to angle R. Okay, then same thing is, because I know this is the normal for the surfaces, this will be 90 degree, which means automatically this angle here will be 60 degree. Okay, so if this is 60 degree, left side 60, right side 60. So the remaining angle that I'm looking at for here will be 60 degrees. So it's what we call equilateral triangle, or what we call angle in the triangle will add up to 180 degrees. So this guy automatically will be 60 degree. And if this is 60 degree, same as before, if this is the normal for the surfaces B, which is 90 degree, this will give me the angle incident here, angle of incident at B, to be 90 degree minus 60 degree. Okay, end up will be 30 degree. So according to the question, angle of incident at B will be 30 degree. Okay, now just a reminder, same as previous video. Okay, if you're looking at this question, if you only want particular review of certain questions, so just scroll to the respective questions. Okay, don't need to listen from like at the beginning all the way to the back. Okay, just get the question that you need. Okay, if you need section B, okay, by all means go ahead and scroll to the section B section. Okay, and start watching from there. But at the same time, okay, remember, understand the concept. Don't just memorize the answer. Don't just memorize the working. Okay, understand the concept. Look at how I solve it. Now, question 4. Okay, now question 4 is it will be a long question. So let's take a look at how I'm going to solve it. The answer will be actually quite standard. Okay, so for example, if I have a person here, okay, so let's say if I have a mirror, okay, let's say if I have a mirror, okay, I have a mirror here. So I want to look at how far the mirror is. What's the length of mirror I need? Okay, so let's say I give a rough estimate. The height of the person is here. Okay, the eyes of the person is here. So let's say this is the height of the person. Let's say it's a standard guy. Okay, 1.8 meter. Okay, so based on the question is this: front of the mirror should be able to see his whole image. Whole image means what? So based on his whole image means at the eye here, he should be able to see his feet. Okay, at the bottom here. So which means he will be able to see his feet. Okay, so which means his feet, he will be able to see his feet. And the feet, light ray from the feet should be able to enter the eye so that he can see his feet. So at this particular, we'll be seeing his feet at this particular location. So this is what we call the lowest level of the mirror that is required. So same thing is, at the same time, he should be able to see his head, because the top of his head will be the maximum place that he can see. So which means that top of his head, okay, he should be able to, a light ray will be able to come through and enter his eye. Okay, so this is where let me take a look. He will go to the mirror and he'll reflect back and he go into his eye. Okay, so this is, it should be a solid line. Okay, this way. So for him to see his height, okay, for him to see his whole image in the mirror, his mirror must be able to see his top of the head and actually the base of his feet. Okay, so this is where the two area is. So from here, will be the top of the mirror, and this will be the bottom of the mirror. So in the fact that the length of mirror that he needs to see his whole self is actually here. This will be the length of mirror that's required. The length of the mirror that's required. So how do I know the length of the mirror? Okay, here we'll use a bit of what we call your similar triangles and your bisector. Okay, let's take a look. Okay, so let's say for this question here is this. Now, for this particular area is, because I know based on angle of law of reflection, the normal is here. Okay, so which means that the angle of incident here and the angle of reflection here will be the same, which will means that this dotted line, okay, would actually be the bisector for this height here. So for example, this will be the height I'm looking at, okay. So which means the dotted line, the normal for the blue ray, okay, the normal for that particular ray, okay, will be the bisector for the height, which is the black in color. So which means that these two parts actually will be identical. Okay, because the angle R and angle I are the same angle, or what we call angle bisector. And when you have an angle bisector, you will find that these two heights, these two sides are actually identical in length. Okay, so they are identical in length. Same thing if I have the same property for the red color ray, the top ray, the same conclusion I can infer from. So for example, if I have the normal, so same thing here, this is a normal. Okay, so which means that the height here, okay, these two rays will be identical. These two rays will be, these two lengths will be identical. Because I have a perpendicular bisector whereby I have, because I have angle R and angle I, they have the same height. And because they have the same height, the base of this triangle will be divided into half exactly. So which means that if I have this particular side, let's say I label this as A, this black color ray as A, okay, below will also be A. Okay, identical, because these two are identical. So which means that if I have a ray, okay, I zoom in here. So if this particular length is B, this particular length will also be B. You know, because I have a perpendicular bisector there. So within the two lengths at the top and the bottom will have be of equal length. So which means that, okay, if you look at the math carefully, so which means that if I have B plus B and A plus A, okay, A plus A, okay, this B plus B plus A plus A will actually be equivalent to the height of the person. Okay, and it's just nice that if you look at the proportion, the geometry, okay, of the mirror, the length of the mirror is actually your L here. This is the length of the mirror L, which is here. Length of mirror actually consists of A and B. So when I say L, is actually I'm saying that it consists of the length of mirror is actually consists of A and B, which is L. Indirectly, I'm saying that A plus B is L, which means that A and B will also be L. So in other words, I can say that L plus L will be actually to be 1.8. So what is the total length of mirror I need to see myself, which I am 1.8 meter tall? Maybe 2L equal to 1.8. L will be 0.90 meter in length. Okay, so if you look at the math, if you use the math, okay, you'll find that for me to see the entire image of myself in the mirror, I don't need the full length mirror. The full length mirror is redundant. All I need the length of the mirror to be is actually half of my length. So if you are a 2 meter tall guy, okay, you will actually need a 1 meter mirror to actually see the full height of yourself. So similarly, if you are a 1.6 meter guy, okay, you 1.6 meter guys, you actually only need 80 cm long mirror to see yourself. You don't need a 1.6 meter ruler. So in other words, it's like if you have a 1.6 meter height, you literally only need half of it, which is 0.8 because of geometry. Okay, so for this question, okay, if you are still not clear, okay, remember to go back to the drawing, okay, just rewind it, scroll back. look at how I cut the geometry, how I cut this particular image here, okay, into using geometry, using perpendicular bisector. Okay, and in short, okay, you'll find that if you use perpendicular bisector, you'll find that every time whatever height you have, okay, you only need half the height for the length of the mirror. Okay, so you actually don't need a full length mirror to see a full self. Okay, now for question 5 here, the easiest way to do, I would say, is just use the long way, whereby I actually draw out each of the image to have 100% of confirmation that whether I can see each of the dot. So what I do is now, the rule that I'm looking at is, remember, the first rule that we have, the first property of mirror is that the object is equally as far behind as in front of the mirror as it is from behind the mirror. So for example, how do I see question, how from, if I'm X, okay, will I be able to see point 1, 2, 3, 4, or 5? Okay, how many points will I be able to see? Okay, so the easiest one, like I mentioned, is to use a property. So let's say if I use a ruler, let's say I use a 0.3. So what I do is I will measure the length of the object, okay, how far the object is in front of the mirror. Then what I do is I will use the same length and I will measure, okay, the same amount of distance behind the mirror. Okay, so this, the green color one, will represent where 3 is behind the mirror. So this will be my image of 0.3. So this will be 3 prime. Okay, so what I'm looking at is I'm using the property of mirror. Okay, the object and image is equal distance behind in front of the mirror. So from here, if I'm able to see the image, okay, from here, if the point X is able to see the image, he should be able to see, okay, the ray should be able to enter a portion of the eye. So let's say, okay, the ray should be able to enter the eye. Okay, ray is able to touch the mirror. Let's see, this will be a solid line. Okay, so the ray will come from object 3. It will hit the mirror and the eye at this particular point. I will call this point A. Okay, so how do I know whether I can see? Okay, 2 things. Okay, I'm able to receive the light ray from point 3, and the point whereby the ray hits the mirror at point A is actually within the mirror. So if I am able to achieve all these two sections, I will be able to confirm that I will be able to see point 3 from point X. Same thing, what happened to the other point? Okay, so let's say if I want to use other point, let's say I will not use point 1. Point 1, what I do, same thing. Okay, I repeat the same thing again. So I measure the length, okay, okay, from A in front of the mirror, or point 1 in front of the mirror. And similarly, the image will be equal length, equal distance from the mirror. Okay, so this will be the image of point 1. Okay, so this is 1 prime. So this is the image. So same thing, if I am able to see the image of 1, the light ray should enter the eye at X. Oh, so sorry. Okay, my eye is at X. Okay, my eye is at X. Okay, so if I'm able to see image 1, okay, the ray should actually enter from the image. You should be able to enter my eye. Okay, and for me to see the image, okay, of 1, okay, from the mirror, the light ray should be or must actually intersect or must incident on the mirror himself. So for this case, right, the light ray, I perceive the light ray, I will see an image of 1 from this blue color ray, and the ray should actually hit the mirror at this point. Okay, but the problem is this point, it doesn't coincide with the mirror. So you see, this point is not on the mirror. So it means that I cannot see point 1, because the light ray from point 1 will not hit the mirror. Okay, it will hit on the left side of the mirror, and thus I will know that point 1, okay, I will not be able to see from the mirror. So what you need to do is you have to actually repeat 1 by 1. So after doing point 1, so what I do is I will repeat this for point 3 and point 4. So let's say example for point 2 again. How will I know point 2? Am I able to see point 2 or not? So what I do is I repeat the same thing again. A length of point 2 from the mirror. And similarly, I should have the same distance behind the mirror. Okay, so this is 0.2. Okay, so 0.2 will be here. So this will be what I call 2 prime. Okay, so if I'm able to see the mirror, my ray should actually, the ray from 0.2 should actually enter the eye at any point. Okay. And it should also, the light ray, and it should also hit the mirror. So if I'm able to see 0.2 from the mirror, two things must happen. I must be able to see the light ray entering my eye from the image of 0.2. Second thing is that the light ray must hit the mirror. And here you take a look, light ray from 0.2, from the image 2, it hits at this point, which is not on the mirror. And thus, I will be able to conclude I am not able to see the 0.2 views on the mirror. Okay, so from here, I can conclude actually I cannot see 0.1 and 0.2. I can actually see 0.3. So how about 0.4 and 0.5? Same thing, I will repeat and for 0.4 and I will repeat for 0.5. Okay, this method of doing right is a bit tedious. Literally, you need to try all the points. Okay, there are faster way to do it. Okay, you can take a look at what's available online or what's available on textbook to find any shortcut. But among all the shortcuts that I see, right, I realize that this method, although it's long, but this method is what we call foolproof. Is that it works for any situation, it works for any image, it works for any situations or scenarios. So that's why I actually prefer this particular method, although it's a bit tedious. We just take note of it. Now, question 6 is the typical, I would say it's a refraction question that involves total internal reflection. Now, for question 6, right, the most obvious one is you need to take note of this point. Based on the question is that from medium 1 to medium 2, you'll find that there is a total internal reflection. So the moment you have a total internal reflection, okay, the property of total internal reflection, one of the big properties is you must make sure it always travels from optically dense medium to less dense medium. Okay, so automatically, if I have a reflection, total internal reflection occurring between medium 1 and medium 2, I can actually conclude that medium 1 is optically denser medium. And automatically, I also can conclude that medium 2 is optically less dense medium, because internal reflection only occur first condition when it is at from the light ray traveling from dense, optically dense to less dense medium. That's the first rule. Second rule is angle I is always more than angle C. So with this in mind, you will find that based on the situation, you will automatically know that actually 0.1 is true already. So the moment you know 0.1 is correct, statement number 1 is correct, A is correct, you are very sure that point A is correct. So actually you can just highlight the answer and you can just clear this question straight away. Question 7. Question 7 actually is I would say is a giveaway question. Okay, here I'm looking at, okay, if this is the normal. Okay, if this is the normal. Okay, if this is the normal, okay, light ray entering, this is air. Okay, this is glass block. So this will be dense, medium. This will be less dense, medium. So the light ray should actually bend towards normal. So the light ray should actually be traveling at any angle except, which actually be traveling at an angle less than this. So actually the light ray, because it bends towards the normal, it should actually be traveling less than that. Okay, so he should not be traveling here. So the light ray should not be traveling here. It should be traveling less than that. So it should be somewhere here. Okay, so the light ray, because it bends towards the normal, it will actually hit any point somewhere below, above B. Any point here should be possible. And that's why I know that, okay, it would be at A. Okay, because light ray, when it travels from air to glass block, it actually bends towards normal. Question 8. Okay, question 8. Let's take a look. Let's take a look. Now, question 8. Now, to look at question 8, okay, based on the information given, right, the easiest way or the faster way to do question 8 is that the students must actually know the 6 diagrams for lenses thoroughly. For example, if the question says if I'm placed 21 cm from the converging lens, the image should be slightly smaller than the object. So based on 21 cm, this is the yellow color one, it will be actually at more than 2f. So the first statement, from the first statement, the outcome, you can know that at 21 cm, it means that the object is actually more than 2f. So which means you will know that 21 cm is actually more than 2f. Okay, so which means I can actually conclude, based on this statement, I can actually safely conclude that 2f, okay, is definitely slightly less than 21 cm. Okay, because the question says if I'm placed at 21 cm, my image will be less than the object. So which means from the first case, I can conclude that the image or the object is placed more than 2f. And from here, I also can conclude that 21 cm is definitely much more than 2f. Second statement, okay, the statement states that if I'm placed at 19 cm now, the image form will be larger. So if you look at the two diagram here, larger, it will mean magnified. The image is larger. So which means that if I'm larger, right, which means that my object distance, which is 19 cm, it must be between f and 2f. So my object distance now is actually between f and 2f. So which means that for the first case, the yellow color one, okay, for first case, if I can conclude that at 21 cm, I am more than 2f. 21 cm is more than 2f. Okay, at the second case, 19 cm is in between f and 2f. So which means with these two information, right, I can roughly have a good estimate that, okay, if 21 cm is more than 2f, 19 is below 2f, okay, so I can actually safely conclude that 20 cm will be somewhere in between here. 20 cm will be roughly 2f. Because from the first case, case 1, I can conclude that it is this particular situation whereby the object is actually more than 2f. For the second case, I can conclude that the object is actually slightly lesser than 2f, slightly lesser. Okay. So which means I can roughly have a good estimate to say that the 2f of the question is around 20 cm. So 2f is around 20 cm based on a good estimate. So which means I can actually conclude that f is roughly around 10 cm. Focal length of the lens is roughly around 10 cm. And from that, I will have the answer B. Okay, this is how I use the 6 diagram, the lenses diagram, to have a good estimate of the situation given. Okay, so students, for this case, right, this particular case, you must remember that you need to be thoroughly well versed in your 6 diagrams. Okay, the 6 lenses diagrams, what are the properties, what are the image, what are the locations, and what are the users for it. Question 9 is quite straightforward. Okay, you know that the intersection of the point here, the image, this is actually the image if it's focused. This will be the intersection, will be where the image is focused. Okay, so now my screen is on the left side of the image. Okay, the cross side, this intersection. So which means automatically this image here, this is the image. This image here will not be clear, or what we call blur. Okay, so what I do, the easiest way to make it, to make the screen, to make the object, to make the image clear, there are 2 ways. One is I move the screen nearer. Okay, I actually move this screen nearer here to this particular location. So if I can move the screen to the, intersection, I should be able to have a clear image form on the screen itself. Okay, but sad to say now the choices allow me to do that. The other way you can do is you take a look at the 6 diagram. Okay, now if you look at the 6 diagram, especially diagram number 2, 3, and 4. Okay, diagram number 2, 3, and 4. We have actually one properties or one particular pattern that is surfacing. For example, for diagram 2, 3, 4, right, you'll find that as the object go nearer, okay, from 2f to f, and from 2f go in between f. Okay, so from here, the object is actually getting nearer to the lens. Okay, and one property when you see that when the object is going nearer to the lens, you look at the image. The image is actually in between 2f, at 2f, and more than 2f. The image is actually getting further and further. So the image is actually moving further. Okay, so if you look at question 2, diagram number 2, 3, 4, right, you will find that as the object actually moves nearer towards the lenses, you'll find that the image actually move further away from the lenses. So that's one of the property that you see from ray diagrams, these 6 diagrams. So which means that if I am able to shift my object closer, if I'm able to shift my object closer to the lens, my image here will actually shift further away from the lens. And because of that, I should be able to make the new image fall on the screen here. Okay, and as such, this method will actually give me actually a more a clearer image, a more focused image. Okay, so that's why I say from question 8 and 9, right, you actually give us a good example, concrete hints for students that you have to be very well versed at these 6 diagrams to know what lenses is about. Okay, question 10, same thing. If you look at the diagram here, okay, the easiest way is do a simple estimation. You take a look based on diagram, this particular diagram. Let's say if I shift this ray, let's say if you focus on this particular ray, okay, you'll find that, okay, this blue color ray, you'll find that if I were to tweak this ray down, okay, if I were going to rotate this ray down a bit, okay, let's say if I'm going to rotate this ray, if I'm going to tweak this ray down a bit to C, okay, let's use a different color. If I'm going to tweak this ray down to C, the particular refracted ray from the lens will actually move up. Okay, so this is the ray diagram that you have. So what I'm doing is I'm actually doing a rough estimation of tweaking this ray down towards, okay, further down a bit, and you'll find that the refracted ray will actually move up a bit. Okay, so this is what we have if we do a rough estimation of the lenses. And because the moment I tweak here, right, you'll find that this ray cuts through this point and this ray is perpendicular. Sorry, it's not parallel, it's parallel to the principal axis. So this ray is what we call the ray number 3. Ray 3, which will cut the focal point and it will travel straight parallel to the principal axis. So which means that if this point C is my focal point, C, okay, so for me to produce a virtual image, my object must be less than F. So if my F is at C, this is my focal point. For me to produce a virtual image, I must be less than F or point C. So which means my image, my object must be further inside the lens, further towards the lens, aka it will have to be at location point D. Point D will be the only choice that will satisfy the condition U less than F. Okay, so when U less than F, based on the ray diagrams, I will get a virtual image which actually satisfies the question. So here, what I'm doing here is I'm doing a rough estimation of actually tweaking the ray. So if I'm able to deduce from the blue color ray, based on the blue color ray, I'm able to deduce the next ray, which happens to coincide with ray number 3. I will be able to have a rough estimation of the focal point of the lens itself. And from there, I will be able to deduce which location will produce a virtual ray. Okay, now for section B here, the ray diagram here, ray diagram, same thing, nothing fanciful here. Okay, the key things I'm looking at is the question look at asking the students to draw the ray diagram from point X, which is somewhere here lah. Okay, so students must draw the rays from point X or to show how the eye actually see the object. Okay, so same thing. The first rule that we have, okay, how do I get the ray diagram below here? Okay, I will take a look at it working here. So now the easiest way to do is back to basics. Okay, for ray, the object, how far the object is, okay, it must have the same, how far the object in front of the mirror, it will have the same distance, the image will have the same distance behind, okay, the mirror. So which means at this point, okay, this will be my X prime. Okay, so this X and X, this is the object, this will be the image. Similarly, what I do here is same as before, like I told the class, okay, you have to draw 2 rays that enter your eye. Okay, so from point X, the eye will perceive that the ray, okay, come from the image and ray travel in straight line. So the first ray will actually be this way. Okay, enter the eye. Okay. Same thing, rays that is behind the mirror, it has to be dotted lah. So remember, it has to be dotted. And same thing, ray that's in front of the mirror, it has to be solid because it's a real ray, so it must enter the eye. So what I do now is, at this point of intersection here, okay, this ray, the ray actually come from one place only. The ray actually come from the object. So this ray will actually be connected back to the object here. Okay, and the light ray actually come from the object. So the arrow must come from the object. It enters the eye here. So this is ray number 1. So what I do now is with this pattern here, with this working, okay, what I call step 1, step 2, and step 3. These 3 steps, I use these 3 steps to draw one ray. So what I do is I will just repeat it for the second ray from the same point. Okay, so this is what happens. So eventually you will have 2 solid ray, 2 real ray, okay, which is here. Okay, 2 real ray that enter your eye. And similarly, you will have a 2 virtual ray that's enter your from the image here. Now, one thing to take note is this, okay? While you draw the ray diagram, you have the correct ray diagram, right? Please take note, you have to make sure that the image behind, image C from the mirror is always virtual. Okay, image, it has to be virtual, so it has to be represented by a dotted line. Okay, so it's a dotted line, so take note of it. Okay, so once you have it, okay, you will have the answer, okay, and you will get all the marks that you need. Okay, 1 mark for one ray, basically. Next, okay, question 2. Yanis is 5 meters in front of the plane mirror. Okay, the easiest to, I would say this one, nothing much. If the mirror is here, okay, if Yanis is 5 meters in front of the mirror, okay, if Yanis is 5 meters in front of the mirror, the image, okay, will be equal distance in behind the mirror also. So this will be 5 meters. So common mistake. Remember the question asking for Yanis, image between Yanis and the image. So the question is actually asking for these 2 distances, which is 5 plus 5, 10. Okay, property of image, I will not dwell too much. Everybody should know, okay, all of them. Now, this is the problem. Okay, this is the next question. So the easiest is, let's say, we do a drawing. So this is the mirror. So this is the 5 meter. Okay, so this is the image. Okay, so this is the 5 meter. So it's easier if you draw the answer question out. So now what happens if Yanis start to run from away from the mirror at 2 meters per second. Okay, what is the image after 3 seconds? Okay, so now let's take a look. 2 meters per second. Okay, so which means in 1 second it will be 2 meters. So indirectly I'm saying that in 3 seconds it will be 6 meters. Okay, next, if I say running away from the mirror, so literally Yanis is actually going to the left side. Okay, so you're going to the left side. So which means in the 3rd second, Yanis will be 6 meters away from the mirror. So at time 6, I will use the red color pen. So the red color pen at time 6, oops, what happened? Okay, at 6 seconds later, Yanis will be here. At 3 seconds later, Yanis will be here. Okay, which means she has ran another 6 meters. Okay, so from time 0, this is time 0. Then this is time 3 seconds. So at time 3 seconds, Yanis actually run another 6 meters already. Okay. So at time 3 seconds, actually Yanis is actually, at the 3rd second, Yanis is actually ran 6 meters and Yanis is actually 11 meters from the mirror. So if I keep going back to the basic, the property of mirror, which means the mirror, the object, the image will has the new image at 3 seconds will actually be the same distance as Yanis in front of the mirror. So now Yanis at 3rd second, he's 11 meters from the mirror. So which means the image will actually be 11 meters from the mirror here at the 3rd second. So the total distance between Yanis and the image at 3rd second, it will be a simple 11 plus 11, which will give you 22 meters. Okay, so this will be the easiest way to see, basically. Okay, now what's the speed of Yanis moving away from the image? Okay, there are 2 ways of getting this 4 meters per second. Okay, one way is by common sense. Okay, so if I know that Yanis is moving away at 2 meters per second, Similarly, I will know that the image will also be moving away from the mirror at 2 meters per second. So if left side 2 meters, I run 2 meters away, image also run 2 meters away. So the total combined speed will be actually 4 meters running away from each other. So the speed will be 4 meters per second. Okay, that's what we call by common sense. Okay, so if you don't want to do this method, you can do the going back to basic using mathematics. Okay, distance will be, okay, distance between the two of them. Okay, distance between the image, first one, between Yanis, it will be 22 meter. So it will be 22 meter. That will be the at time 3 seconds. Initial speed, initial distance, final distance. Then the initial distance between them will be 10 meter per second. Okay, so 22 minus 10, you divide by 4. Okay, so total you get answer will be 4 meter per second. So sorry, made a mistake here. It's not 4, it's 3. It's 3 seconds. Okay, so this should be 3 seconds. So it should be 3 seconds. So sorry, my mistake. Because the question said after 3 seconds, not 4 seconds. Okay, so it should be after 3 seconds. So it will be 22 minus 10, which is the total change in distance, divided by the time taken, which is 3 seconds. So you get 4 meters per second. Okay, so if you look at this type of question, right? If you look at this type of question whereby the image of the object running away or moving towards the mirror, I will find that the easiest way to actually answer it actually is to by draw the answer out. Okay. Now, question 2. Okay, now refracting index, nothing. This question I will not say is difficult. Just a side note is that students must always remember, okay, the formula for refracting index. There are actually 2 formulas for refracting index. One is based on the angle, okay, which I always write this. Dense medium is actually sine of angle in less dense divided by sine of angle in the dense medium. Or refracting index is actually, okay, speed of light in vacuum divided by the speed of light in that particular medium. Okay, these 2 formulas students must remember, because these 2 formulas in the sense that you can't derive each other basically. So if the question, like for example 3A require you to calculate it in terms of to calculate the speed of light in a certain medium. So if you forgot it is about this second formula, if you only remember the first formula, there's no way you can do 3A1. Okay, so just take note of this. Okay, then other than that, common things you have to take note is the speed of light 3 times 10 to the power 8 meters per second. Okay, and and must remember, okay, if you're using sine cosine, remember to keep it in degree mode, not radian. Now, same thing is point A. Why isn't there any refraction taking on at point A? Okay, why isn't no refraction at point A? Let's take a look at point A here. You find that the ray is hitting the surfaces at point A head on. Okay, which means this particular point is also in line with the normal of the surfaces. Which means that at this point, oops, what happened? So at this point, okay, this particular angle here, I'm looking at the angle of this light ray. Okay, the angle of incidence at this light ray is actually 0 degree with respect to the normal. Remember, light ray is always measured from the normal to the ray himself. So although I'm hitting the surface perpendicularly, okay, but my angle of incidence is actually 0 degree. So if my angle of incidence is 0 degree, okay, or perpendicular 0 degree, there will not be any bending. This is the only angle that there will not be any bending. So you must remember. So then what happened in question part C, point B. Point B, remember, point B, this particular question is a 2-part question. Okay, in this part. Meaning that at point B, right, the moment I hit point B, I need to explain what happened. And based on the question is that, state how the ray will travel after point B. Okay, so here you must decide what will happen, because there are 2 possible answers in this case. Okay, at this point, right, here you must be careful. You cannot conclude that it will bend away, it will bend away from normal, you will exit and bend away normal, because at your syllabus, right, there are 2 possible cases. So now at point B, right, the ray will actually behave this. It will either exit and you'll bend away from the normal. You either exit and bend away from the normal, or it will actually do a total internal reflection and it actually reflect back to the surface. Because at point B here, right, the medium is actually, the light ray is actually traveling from optically dense medium to optically less dense medium. Okay, to optically less dense medium. So this is the problem. So in this particular case, right, you have to be careful, because it could be either the light ray will exit the glass block and do a refraction, whereby it bend away from normal, or actually you will do a total internal reflection here. Okay, so what we are looking at is this. Okay, so now before we can do anything, there are some check that we need to do. So first thing first, we need to identify what is the angle of incidence first. For this light ray, right, angle of incidence is here. Based on the mathematics, this angle is 45 degree. No, sorry, my mistake, 35 degree. Okay, this angle here is 35 degree. Okay, so angle of incidence is 35 degree. Okay, so angle of incidence here is 35 degree. And based on the question, right, the reflecting index of glass block is actually 1.55. So if you do the math, right, to work out the critical angle yourself, you'll find that, okay, if I critical angle of glass block, okay, so critical angle of glass block, it will be, okay, this is the formula, okay. So you'll find that angle sine C will be 1 over 1.55. And you'll find that the angle of critical angle will be 40.1 degree. Okay, so these are the two things that you need to prepare yourself before you can do any before you can write out the conclusion. So from here, you know that the angle of incidence is angle 35, and you know that the angle of critical angle is 40 degree, 40.1 now. And the object is actually going from dense to less dense medium. Okay, so it actually, so the light ray is actually from optically dense to less dense. Okay, so these are the three information that you have. So if you compare to these two, right, for internal reflection to occur, okay, take note, your internal reflection to occur, your angle I must be more than for angle C, 40.1. But in this case, okay, you'll find that the angle of incidence is actually less than critical angle. So that's the first statement that you must make. Of light ray will not be refracted, will not be internal reflected. So that's the second conclusion, first conclusion. So you actually rejected these two, you rejected, okay, you actually rejected TIR already. So TIR is one of the conclusion. You actually rejected already. Then after that, once you rejected TIR, then you only left with refraction. So if it's refraction, right, you have to tell the marker whether it's refract away from normal or towards normal. So you must tell the marker which of the answer are you looking at. So the only way to tell the marker which is you must look at the speed. So if you look at the speed, you will find that as it travels from dense to less dense, the speed of the ray increases, and because of speed of the ray increases, the ray will actually bend away from normal. So for this type of question is for students that you have to be careful is that you must actually explain why TIR don't occur. Second, you also must explain if I refract, which of the refraction situation will occur. Why refract towards normal or why refract away from normal. So only when you satisfy all this, then you can actually conclude the correct answer. Okay, so you have to be careful of what you're doing. So that's what I mean by this question is a two-part question. So we look at question 4. Question 4 here is a lens question. So normally what we have for lens, right, is I always tell students that there are always 3 basic ray that you draw. So among the 3 basic ray, right, we always draw ray 1. Ray 1 is the ray that passes through the optical center, okay, of the lens. So this is the ray that I always ask students to draw. You must always draw the first ray first. Okay, so have a habit to always draw ray 1 first. Okay, but then ray 2 or ray 3 depends on the questions to see which is more suitable. But always have the habit to draw ray 1 first. Now, based on the question is that the object is actually placed 2 cm tall. It's 2 cm tall, is placed 8 cm from the center of the lens. 8 cm. So based on the question here, this will be 1, 2, 3, 4 squares. So 1 square will be 2 cm. So this is what we call 8 cm from the lens. Okay. Now, I have a focal length of 3 cm. So focal length of 3 cm. Okay, so based on information, focal length of 3 cm. So this information is represented on the lens as in where 3 cm from the lens, focal length of 3 cm, it will mean the F will be here. Okay, so this will be the focal point, capital F. Okay, so in the sense that this is actually your 3 cm. Okay, so just take note of this. Okay, in this case, because it's drawing by scale, so you have to be precise. So your focal point is 3 cm based on the question. So same thing is eventually the question will ask you to locate the image, okay, determine the height and the distance of the image, okay, height and the image of the distance and height of the image. So basically it's asking you to draw the ray diagram, okay. So now let's look at it, okay. Every time we draw, we always have the habit to draw the ray number one, ray one. Ray one passes through the optical center, okay. Let's say we use the head, pass through the optical center, okay. So this is my ray one. Same thing, always draw arrow, okay, to symbolize ray diagram. So this is ray one. Oopsie, sorry. Yeah, let's accurate a bit. So this is ray one. Now ray two, okay, ray two, okay, there are a few ways, okay. Either you can draw perpendicular, then you cut the focal point on the other side. Okay, remember focal point is equal on both sides. So if the lens is 3 cm on the left, the focal point is 3 cm on the left, it will also be 3 cm on the right. So this will be the focal point for the lens here. So what you do, okay, I can use ray 2. Okay, ray 2 is the ray parallel to the principal axis. Oh, see, let's look at the ruler. Okay, let's look at ruler. Okay, so this will be, okay, ray 2, it will be parallel to the principal axis. Okay, so upon hitting the ray, it will actually bend and cut the normal, cut the focal point. Okay, so after hitting the lens, okay, ray 2 will cut the focal point. So you cut the focal point, okay, you have to draw as accurately as possible. Okay, cut the focal point. After they'll go straight through. Remember, okay, draw the arrow. Okay, then after that, the intersection point will be the image. Okay, so in this case, you can see very obviously it's a inverted image, so it'll be a real image. So same thing, solid line for real. Okay, complete the diagram. So this will be the image, upside down one, inverted. Okay, and this is what happened to the answer here. Okay, so if you don't want, like me, I use ray 1 and ray 2. So if you don't want to draw ray 2, okay, so let's say I don't want to draw ray 2. Okay, so let's say I don't want to draw ray 2. Okay, so I will use ray 3. Ray 3 cuts the focal point first. Okay, so ray 3 cut the focal point. Okay, so ray 3 cut the focal point. Then after that, what it does, it travels parallel to the principal axis. So it travel parallel to the principal axis. Okay, and this will be your ray 3. And same thing, after drawing the straight line, okay, draw the arrow. Okay, this will be the ray 3. After that, same as before, intersection point here will represent the image. Then after that, you complete the image. Okay, real upside down means it's real. Okay, so if you draw carefully, okay, all both diagram will be correct one. Okay, whether you use ray 1, ray 3, ray 1, ray 2, it doesn't matter. You just use the one that is more convenient for you. But always remember, have the habit to always draw ray 1 first. Okay, then after that, same thing. Once you get the answer out, okay, so what you need to do is remember, label the object, label the image I, because the question says so. So look at the question, label the image I. Then after that, based on the question is, you are supposed to measure the distance of the image from the lens, which is here. Okay, which is the image distance V. Then you're supposed to measure the height of the image, which is here. This is the height of the image. Okay, so you measure the image carefully based on the scale. Okay, so now for the next question here is like what I mentioned. The question purposely give you the image and the object. So now for the same object, okay, I give you, now in this case, I give you the image, okay, and the object. So no lens is given to you. So now your objective now is actually to find the lens and actually the principal focus of this new lens. So same thing is, although the question is different, but the approach is actually the same. Okay, so every time you do is always have the habit to always draw ray 1 first. Ray 1, sometimes I call this the lens locating ray, because it allows us to locate the lens. Why? Let's take a look. Okay, for the ray diagram number 1, ray 1, okay, you always look at ray 1 always cuts 3 points. You always cut the object, you always cut the image, and in between them, they always cut the lens. So for example, if you combine these two, let's say you combine this principle for ray 1, you will actually touch the object, touch the image, and touch the lens. So this is what happened. Okay, so this is your ray one. Ray one will always come from the object, go to the image. And what happened here is the intersection here, this point will actually be the lens, location of the lens. Okay, it will be the location of the lens. Okay, so this is actually the lens. Okay, use a ruler. Okay, let's say let's to be accurate. Okay, let's use a ruler. Okay, so this will be the lens. This will be the lens, location of the lens. Okay, so this will be location of the lens. Okay, so this will be location of the lens. Remember, lens symbol for the lens is you have two arrowhead towards the head, two arrowhead. Okay, so this will be the symbol for the lens, L. Okay, I'll label it L because why the question says so. So this will be the location of the lens. Remember, ray one has this unique property that it will actually touch the lens at the optical center at the principal axis. So this is where I find the lens. After that, what happened is you'll find that whether I draw ray 2 or ray 3, example, if I draw ray 2 will always be parallel, okay, to the lens. Okay, parallel to the principal axis. So ray 2 will be parallel to the principal axis. Okay. Then what? So let's say, okay, so ray 2 in principle, it will be parallel to the principal axis and it will cut the lens. Then after that, what happened? It will cut the focal point and it will hit the image. In this case, I don't know where's the focal point, but I do know that it will hit the image at this location. So what I do is I just adjust my ruler. So it will definitely hit the image. Okay, you will definitely hit the image from the lens. So this is where I cut through. Okay, and same thing. Ray diagram light ray always come from object, go to the image. And for ray diagram number 2, ray 2, when it cuts the principal axis, this is where the focal point is. So this is my focal point. Okay, so once you are done, you'll find that you located the focal point, okay, which is on the right side. Same thing, it will be the same location on the left side also. So this is the focal point, and this will be the position of the principal focus. Okay, so I will label it as F. Okay, so from there you will actually, once you're done, you actually solve all the question already. So this will be the final answer for the entire question. So what I'm looking at is you compare question 5A and 5B. Okay, sorry, 4A and 4B, you'll find that their ray lens drawing, their ray diagrams, okay, where I deploy ray 1 and ray 1 and ray 2. But the question is slightly twisted in a different way, but it should be what we call under the acceptable range, whereby the students should actually be equally exposed to different type of question. Okay, so it could be like, so for under lens diagram, you have to make sure you need to know how to draw lens. There are always 3 different scenarios: object, lens, and image. So sometimes the question will give you object, you will give you the lens, you are supposed to find the image. Sometimes the question will give you object and image, you are supposed to find the lens. And on the third particular scenario, whereby I actually give you the image, I give you the object, and I actually you are supposed to find me the object himself. Okay, so 3 different scenarios, 6 diagrams. So total 3 times 6, you got 18 version of that diagram. So you have to be equally well versed in all the particular diagrams. Then after that, last but not least, the question says, as the object move nearer to the lens, okay, and the image will disappear, what will happen? Okay, now you take a look. Okay, based on the question here, you will find that the image, the current location of the object, the current location, the object, okay, the current location, the object is, okay, the object distance is more than F. Okay, object distance is more than F. So as I approach the lenses, you'll find that as I approach the lenses, okay, object distance actually approaches the focal point, or in fact it becomes less than focal point. So if I keep moving on, right, you'll find that object distance actually get nearer to the lens. Okay, so get nearer to the lens. Okay, now, and what happened is you will find that if you look at the ray diagram here, let's say I put a picture here, okay, you'll find that as the object, currently the object is at more than F. Okay, currently the object, based on the question, this is where the object is now. So as I move nearer towards F, you'll find that the object actually is approaching this diagram number 5 and diagram number 6. As the object get further and further, as the object get nearer and nearer to the lens, the object get bigger and bigger. Sorry, what am I saying? Sorry, I repeat. When the object get nearer to the lens, you'll find that the image get bigger and bigger. And one of the unique characteristics is that as the object get nearer to the lens, the image actually changes from real to virtual, or what we call it changes from inverted to upright. Okay, so these are the properties that we are looking for. These are the answer that we are looking for. So as the object move nearer to the lens, you find that the image actually become magnified, blur, and virtual, because now he's approaching from real to diagram number 4 to diagram number 6. So he's approaching the ray diagrams. Okay, so this is what we mean by you need to be well versed in the ray diagram. So you must know which diagram he's approaching. Let's say in this case, it will be diagram number 4, you're approaching to diagram number 5, diagram number 6. Okay, so you must know, once you identify how the ray diagram actually changes, you will actually be able to deduce the answer. So as the object go nearer, the image actually become magnified, and it become from real to virtual. Okay, it become so eventually what we are looking at is the objects will pick up different properties, okay, at different locations. So this is what I mean by lenses, the lens drawing, the lens image. Section C, okay, section C, I will not say section C is difficult. Section C is like a simple application of what I call the Snell's law, refractive index, the formula. So I will not dwell too much. So students, you are supposed to know how to use this formula. Okay, so I will not dwell. Okay, if you have any problem, just leave me a message at the bottom of the video, and I'll get back to you. Okay, if not, actually, it's quite a straightforward. Okay, image. The only thing I need to caution you is when at surface B here. Okay, at surface B here, based on the question, is that it actually does what we call total internal reflections. Okay, so same thing as the moment you see total internal reflections, you must be aware that there are two conditions in total internal reflection. For example, it will be from optically dense to less dense. Okay, and the angle of incidence will be more than angle C. So the moment you see critical angle or total internal reflection, you actually see these two conditions being achieved. And usually most of the time the question will ask, and these two will happen to be the same answer, will be the answer. And true enough, okay, the question will say, take a look, the question will say, hey, how come the ray doesn't emerge from prism at B? Basically asking you, why does total internal reflection occur, or what happened at B? Okay, so the students, other than telling me total internal reflection occur, you also has to tell me the two conditions. Like I mentioned before, dense to less dense, optically dense to less dense, and angle I is more than angle C. These are what I call the keywords for internal reflection, and sometimes it's actually the standard answer. Okay. Then after that, what happened is for Crystal now, he shine a second ray. She shine a second ray, ray C, it hit point C. Okay, one thing to take note is the same ray, so these two are parallel rays. Okay, so when I enter, the ray, okay, the same thing will happen. This will be the same thing will happen at C, will happen at B. What happened at A will happen at C. Okay, so what we mean by refraction, okay, will bend towards normal. The only thing is now, okay, instead of internal reflection, total internal reflection at B, now I have internal reflection at this particular surface. Okay, let's say I call this D. Okay. Then after that, if you look at the path that is going out, okay, important thing is at this point here, okay, you have to be aware that the angle here, angle I here, okay, angle I at this angle here is definitely much larger than the angle I at here at B. Okay, angle at D is definitely much larger at angle at B. So if angle B is already more than angle C, so automatically you can deduce that angle incident at D. Okay, let's give a different color. So this is D. So this is angle ID. Okay, wrong color. So this is angle ID. Okay. So automatically, if angle IB, incident angle at B is more than angle C already. So automatically you look at the dimension, you look at size, you automatically know the angle D, which is always more than, which is confirmed more than incident angle B, which will actually tell us that angle D, angle incident at D will confirm be bigger than angle C. So this will allow us to conclude that at point D, okay, at D, point D, TIR actually also occur. So from here, I can deduce that point D here, total internal reflection has occurred and it will actually internal reflect to hit maybe point E here. Okay, and point E, as before, if you do a calculation, you know that point E will be less than angle C. So I will be able to refract out of the lenses, out of the prism. So that's why I can deduce that C at point E, it will be refraction happening. It will not be total internal reflection because the angle at E, angle incident at E, okay, will be smaller than angle C. And when it's smaller, you will find that total internal reflection will not occur, critical angle will not occur, the normal refraction will occur actually. So that's why the ray actually exits at point E here. Okay, exit point E. Okay, so this is the full diagram for full ray diagram for ray numbers, ray C. Okay, so just take note of this. Okay, so students, you need to actually actively switch between total internal reflections with refractions. So you must really know the condition for internal reflections thoroughly. Okay, be able to use it as and when it's needed in the question. The last question, part C, says that Crystal said that if the whole questions were to conduct in water, okay, remember it's part A, part A is conducted in water, the ray will undergo total internal reflection at B. Okay, now take a look at this, is that if I conduct this whole experiment at B, if I conduct this whole experiment in water, okay, currently now, this is air to glass. Okay, so if I conduct the whole experiment in water, okay, if I conduct the whole experiment in water, okay, you'll find that if this is water, okay, the refracting index of water will actually be much higher as compared to refracting index of air. Okay, so which means that if you compare water and glass, okay, you'll find that the difference in the refracting index between water and glass as compared to the differences between air and glass, the differences is actually smaller between water and air, water and glass, smaller differences between water and glass as compared to between air and glass. Okay, because the refracting index is actually bigger in water. So if you look at the refracting index, the differences between the two refracting index between the two medium, for example, the water and glass, the differences will be smaller. So what happens when you have a smaller refracting index? Okay, when the refracting index is smaller, you find that the bending will be smaller. Okay, because same thing is when I look at refracting index, okay, when I look at bending of light when change in speed, because the refraction occurs because, okay, what happened during refraction is the speed of the light will change. Okay, refraction occur means the speed of light will change, and when the speed of light change, refraction occur, the bending of light ray occur. Now, but fundamentally, what causes the change in the speed of light, what causes this refraction is actually the difference in the refractive index of the two medium. So when I cross from dense, less dense to dense, okay, there's a difference in the refractive index. So which means that the bigger the differences between these two, the bigger will be the change. And when the change occur, the bending will occur. So for refraction, right, the bigger the differences in the indexes, the bigger will be the changes in the speed of light. And because you have a big change in that particular speed of light, you'll find that the bending occur will be larger. So for example, if now the refractive index is actually smaller, the differences between the two medium is smaller. So between water versus glass, okay, the differences between these two is actually smaller now. And because the differences in index is smaller now, the refraction actually will occur at a smaller degree. And when the refraction occur at a smaller degree, you will mean that the angle of incident, the refracted angle B, okay, will actually be smaller. And when angle of incident now is smaller, the chances that it is smaller, okay, or equal to angle C is actually much higher now. So as a result, what happened is if I put everything in water, because the differences between water and glass, the differences is actually smaller, the refracted angle will be smaller now. And what happened is because the angle of incident now is smaller, my incident angle will not be larger than angle of incident. Okay, in fact, because now in water, I will actually have, when my small angle of incident at B will actually be smaller or equal to the critical angle. And when these two things occur, either I'm smaller than critical angle or I'm equal to critical angle, the ray, okay, will be refracted away. So TIR will not occur. So even when I have smaller angle I is smaller than critical angle, or my angle I is equal to critical angle, my ray will still be refracted one. So as a result, what happened is my ray will still exit, okay, prism B. So now if I put everything inside water, okay, my ray, okay, what happened now is my ray, okay, it will actually, the moment it hit B, instead of internal reflection, now actually my ray may actually exit the surfaces, or it might exit the surfaces performing a 90-degree refraction. So these two cases is possible. So you will no longer perform total internal reflection because the differences between the two medium is actually smaller now. Okay, so point to take note for this particular question is the differences in refractive index. Okay, refraction, when we talk about refraction, the bending of light when it passes from different medium, the keyword is actually different medium. When it passes from medium 1 to medium 2, the bigger the changes in the refractive index, the bigger the differences in the refractive index, you'll find that the changes will actually be more obvious. So for example, if I'm going from dense to less dense, I'm supposed to bend away from the normal. So the bigger the differences, the bending will be larger, the changes will be much more obvious. Okay, so here we go. Okay, we have completed the topic for the WA, the last question of WA. Okay, I hope this explanation will be like what you need. So in anything same as before, if you have any questions regarding any section of this question, okay, remember to scroll to that particular section and review and rewatch the question again so that you are clear with the explanation. Okay, but in any time, if you have any questions regarding any section of the topics or any questions regarding physics in Sec 3 and Sec 4, okay, just feel free to drop me a message at the bottom of the command bar so that I'll get back to you ASAP. Okay, if not, okay, just stay tuned for the next video I have regarding WA2 or WA1 or even some revision paper for pure science. Okay, so in the meantime, okay, if you like my video, okay, just give me a thumbs up, okay, and remember subscribe to my channel and remember press the bell so that you will be notified of any new updates I have for my channel. Okay, in the meantime, okay, I got nothing for you. Okay, so stay tuned. Bye-bye.